Hi everyone. Today we are going to learn about the stack, the basic data structure. So first we are going to see the definition of abstract data type. Abstract data type is a type for objects whose behavior is defined by a set of values and set of operations. So here class, if you observe the concept of object-oriented programming, it will be having the data members and the member functions. Similarly, the abstract data type also will be having set of values and set of operations. Normally, in the abstract data type, only the operations what we are going to perform will be specified, but the procedure, that is how the operations are going to be performed, and that is implementation details, will not be given. Also, we'll be having the different kinds of memory organizations. But in the case of abstract data type, what type of memory organization you are going to use, for storing your data will not be shown. So what data, that set of values, what you are going to use only will be given as a part of abstract data type or simply ADT. So as we are telling before also that the implementation details or the procedure involving in performing the operations will not be as a part of ADT. Obviously, the algorithms, which is nothing but a step-by-step solution for your problem given, will not be there in the ADT. Because we are telling that we are not going to give the details of the solution or the how the problem will be solved or how the operation will be performed will not be given in the ADT. So that is the reason why we call it as an abstract, and it is called like implementation independent view. So implementation details will not be given in the ADT. So here goes with the stack ADT, that is ADT for stack data structure. So the principle what we are following for the stack is LIFO, that is last in first out actually. So the element what we are going to put in last will be taken out first. That is the principle what we are going to follow in the stack. So here we are having 6 different operations that can be performed on a stack, that is push, pop, peek, size, is empty, is full. Push is like for inserting an element on the top of the stack. Pop is like to remove the element from the top of the stack. And peek is like to view what is the top of the stack. Size is like we'll be returning the number of element what we are having in the stack. Is empty means like if the stack is empty, it will return true. Otherwise, it is returning false. Suppose if it is like is full operation means, suppose if the stack is full, that is the stack size is static, then we can say whether the stack is full or not. And so if the stack is full function or is full operation will return true, otherwise it will return false. And here you are supposed to observe that is empty and is full are not negate to each other. Because if some of the elements are existing in the stack, then is empty and is full, both will be false actually. And what is the difference between the pop and peek? Pop will be removing the element from the top of the stack and will show you what element you have deleted from the top of the stack. And obviously it depends on the program, what you write. Peek is like it will, without removing the element from the top of the stack, it will just show you what is the top of the stack. Let us see some of the stack examples here, which are in our daily life. So here, these are some of the examples. And here you can see in each and every example, we can remove the element which is on the top only, which is inserted at the end. So which is last in, that will be taken out first. So here, a small animation for a stack of plates. You are inserting plate on another plate one by one. This is a push operation on the stack. And if you see like a pop operation, one element by one element, you can remove from the stack. Like this, you can see like stack of plates. And towers of Hanoi, the towers of Hanoi is nothing but you have to shift all these blocks of pieces from one tower to another tower. Here, 3 towers are there. Actually, from one tower to another tower, you are supposed to shift. So all at a time, you cannot just remove them from one tower and put into another tower, because the rule is small block cannot hold the bigger one on it. So always bigger one should be at the bottom and smaller one should be on the top. And only one by one block only you can move. So for that, one particular tower is given as a help for you. So this is a demonstration, and you can see every time you can remove only one block, and that to top of the stack only you are going to remove. That is whatever is on the top of the tower, that only you are removing actually. Okay. So there will be a huge number of steps. So, one particular option, there are different solutions also. One option I am showing you here. And here I am giving the solution from first tower to second tower movement. Like this, the shifting of blocks from one tower to another tower will be taken place. You can easily observe how the blocks are being moved from one tower to other tower, and at the same time you can observe never a bigger block is coming onto the top of the smaller block, and never we have taken more number of blocks at the same time. So this is how all the blocks from first tower to second tower has been shifted. Okay, this is towers of Hanoi. You can do this implementation using stack example. You can do this implementation using stack. So demonstration of the stack using tennis balls, I'm showing you here. I'm taken static stack of 4 size. So push orange. So orange is being pushed into the stack. Then push pink. Pink is being pushed into that stack. And then push blue. Blue is being pushed into the stack. Pop. So top of the stack will be popped out. You need not specify the element. And here push yellow, push red. And now if you are trying to push black, it will show that stack is full. So you will not be able to push. And continuously we are trying to pop all the elements. And here shows the stack is empty if you are trying to pop out again. Okay. So push, pop, is full, is empty. All the functions have been checked in this particular demonstration. Okay. So this is the basic introduction to the stack data structure. Thank you.